Okay, hope everybody's doing all right today. We are going to finish up the first lesson of our next unit, logic sets and probability. We started talking yesterday about different types of notation. We spent some time talking about intersection, union, complement, and we're going to go ahead and do a few more examples today. Now you have the assignment. We'll go ahead and have the opportunity to work on that in class as well. But tomorrow when you come in, remember we're going to have an exit ticket over chi-squared. I'll give you some time to work on that. Next week, I am looking to have a quiz over this material, and I believe I scheduled it Tuesday. I'll have to take a look at that, but I'm pretty sure the website says Tuesday. But any questions about anything? There is something extremely important due Monday. Okay, the outline. Okay, how are those going? Okay, going great. Remember, you're not writing the paper at this point. I mean, if you want to start writing it, completely up to you. You know, work at your own pace. But I just want to kind of see what you're thinking about the structure. Like, how are you going to make the paper flow from one idea to another, your transitions, okay? And more importantly, looking for the data, okay, whether you're collecting it yourself or if you're collecting it, online. That's going to be due Monday. All right, so if you do have any questions or problems, please let me know. I think we got to here yesterday. I think we were about to go ahead and do these problems, and then we started a little commentary on social society yesterday. So we'll go ahead and finish this up. So I want to go ahead and give you about 1 or 2 extra minutes to go ahead and shade in these 6, because what I'm going to go ahead and do then is just randomly choose some people to come on up and shade the appropriate areas for me. All right. Okay. So this is an excellent opportunity if you're not sure, or even if you just want to check, maybe kind of lean over to your villain buddy. Hey, what'd you get for this shading? If you both agree, probably a good sign. If not, maybe let's talk it out. Okay. And then we have a couple of examples using some Venn diagrams, and then there we go. Let me go ahead and put, let's say 2 minutes. That'd be enough. Yeah, since we're doing this right now, just run very quickly. Yep.
I'm jumping ahead of it. Is that the complementary, or is that...
That's the complement, yes. It's the intersection of C's complement and S. Okay, so that's 2 minutes. You may or may not be done. That's okay. But I want to go ahead and start choosing folks to come up and help us shade the appropriate regions for each of these Venn diagrams here. Now, I know this isn't completely random, but I'm going to go ahead and use the random number generator on this calculator. I mean, it's definitely more random than my just choosing somebody arbitrarily. So 29. Katie is super excited. Okay. I'm just, look, Elizabeth, does it say 29?
Yes.
There you go. Okay. I am not making it up. Okay, so let's help each other out. Okay, let's remember this idea. Disjoint sets are sets that are going to have no elements in common, right? But what does that little tick mark mean? Starts with a C. The complement. Okay, so what's that's asking for is the complement of A. What does that mean?
It's the set that you would add to A to make it a universal set.
Now, it's true. If I take a set and its complement, it always gives me the universal set. So kind of play off that. What would the complement refer to then? Okay, Courtland? There you go. We're talking about everything in the universe outside of that particular set. And that's your question. Would B be shaded as well? Yes. The complement of A is everything in the universe, but not in A. That is perfect. No, that's perfect. Everybody knows where she's shading, right? Everywhere but A. Okay. Good job. Good job. See, it's just that easy and fun. Right, Katie? Look at the big smile on her face. Okay. Well, let's see. Now we want to go ahead and shade a complement for intersecting sets. Okay. So I got 5. And that is Ella. It says 5. I'm not, my baby. Okay. All right, so the definition of the complement remains the same. So the fact that they're intersecting, does it change anything? That's it. There you go. I would shade everything but A, the set that I'm referring to. So the entire rectangle except for circle A. All right, very good. Okay, now I have a subset. There were 2 types we looked at yesterday. Just a normal subset. We're talking about a group within a group. But what was the other one? It started with a P. What kind of subset am I describing? Proper subset. Which kind, a subset or a proper subset, cannot be a subset of itself? Proper, there we go. So the group itself cannot be a subset of the original group when we're talking about proper. When you're talking about just a normal subset, yes, that can happen. All right, so next up, I got 16. All right, so Lizzie's going to show me a complement when it comes to subsets. Okay, so she's shading everything except A. What do you think? Okay, all right. Well, would she shade B in any way? There you go. See, B is the subset of A. It's included, so it's still A. Very good. Okay, 3 for 3. See, that's just how easy it is. Okay. Anybody having trouble so far? Okay. Well, let's talk about complements and intersection. Okay, so intersection, we talked yesterday. This is the capital upside down U. Could also be a capital upside down V. But what does it mean if I'm looking for the intersection of 2 sets? It's what they what? The overlap graphically. Okay, it's what they share. It's what's in both at the same time. What was the key word there? And. There you go. Now, or went for what? A union. Okay, this was a marriage of the 2. It's a combination, making one larger group out of the original ones. Okay, so I've got disjoint sets. So I want to show the intersection of A complement and B complement. So it starts to get a little trickier. Let's see who's coming up. I got 13. Lucas. So shade the intersection of A's complement and B's complement. Okay, so you're shading everything but A and B.
Yes.
Fantastic. That's right. How many people had that right? Okay, good, good, good. Now, not everybody is raising their hands. So what some people have liked to do, done in the past, I've noticed, is look at each one individually before you go ahead and look at the entire thing. Sometimes that can really help people kind of visualize what's happening. So if I created two other little universes here, okay, here's A and B, okay. So there's A, there's B, there's A, there's B. Let's say I wanted to go ahead and just show A complement. Well, you would shade everything outside of A, right? Let's say I wanted to show B complement. Well, there I'm going to shade everything outside of B. Okay. Now, I like the way that Nolan described this just a second ago. We're looking for the overlap. So imagine if I could now take this bottom one here, if I could just slide it over onto the other one, where one is on top of the other, I'm only looking for the shaded regions they both have in common, wherever the overlap's going to be. And you'll notice it's not going to happen for those circles. Okay, so maybe if you broke it down into its little parts, maybe that makes it a little easier if you're having some trouble. Okay, so let's try this next one, intersecting sets. So this time I want the intersection of A's complement with what? B. Okay, I got 23. Okay, Radley. It's amazing. Everybody whose number is chosen just has a big smile on their face. Why are you all looking at me like that? That's weird. Okay. All right, so let's see what we got here. Okay, so he says part of B that only contains B, nothing part of A. It's basically the crescent region. What do you guys think? Oh, we're a little quiet on this one.
Well, see, I wasn't sure if it was a universe because it has to contain B.
Uh-huh.
Because B is not in the universe.
Okay. That is correct.
Game.
What was that? Did he say game? Game. G-A-M-E. Game. G-A-I-M. Gang. Ah, okay. So what does that mean? Well, he just turned around and goes, gang. So does that mean like gang busters?
Bradley.
Oh, you guys still say swag? I didn't think anybody said that anymore. I haven't heard swag in a long time.
No, it's the upgrade.
It's like the upgrade.
Okay, so we don't say swag anymore. You got to do that with your arms, make it look like a circle.
Not everybody does that.
Oh, so it's more like in front. So Jaylee's
It's
just
more like you're like flexing.
Mr. West, are you familiar with
You're like
that. Okay. Okay, nice. All right. Very good. Okay. Okay, so let's talk about it. So another way to work this one, again, think about it in terms of its parts, but before you go ahead and take the intersection. So I'm going to go ahead and draw, here's another universe containing, oh, in this case here, they are overlapping, excuse me. So there's A, there's B, and then I'm going to draw another one right here. Okay, there's A, there's B. Okay. Now the two parts of this statement, I want the complement of A, and then I just want B. Okay. So think about what we did just a moment ago. I'm going to shade each individually, and then just try to imagine if I were to put one on top of the other. Where are we only going to overlap? Well, for A, complement, I'm going to shade everything outside. Okay, just like that. And then for B, I'm just going to shade B itself. Okay, so think about it. What's the only region that they share? The crescent. Okay, there you go. Very good. The canyon of the crescent moon. I don't know, man. For some reason, in the past couple of days, we've been on 80s movies. Anybody know what I'm referring to when I say that?
Yeah, the Last Crusade.
Very good, John Henry. Indiana Jones on the Last Crusade. That was in 1989, yes. No, 89 is close, but it's not the 90s.
So the
Well,
the Berlin Wall came down, so they
14 years after that.
Okay, well, let's at least all agree you weren't born. I was younger.
yeah.
I'm trying to.
Wait,
I'm trying to imagine Mr. West wearing parachute pants.
I did not wear parachute pants. No. What's wrong with the way I dress?
No, there's nothing wrong with the way you dress. Like, how did you dress?
You know, teenage high school Mr. West. I don't know if I should. I don't know. But I wore jeans. I wore t-shirts. That's pretty much it. You know, for the students I've had before, I actually had long hair. In fact, they almost didn't let me graduate high school because my hair was so long.
Wait, what?
Who's a good? Actually, about the length of Mariah's.
No.
Yeah.
That must have been
Okay. Quick story. Because Mr. West is boring. I don't know if I should. Ella, you're crying. You're laughing so hard. You haven't even seen the picture yet. Okay. But I remember. I won't say the gentleman's name, but at the time, good Lord. At the time, one of the assistant principals. I graduated in Monterey, 1995, and I did have really long hair. And are you okay too?
I laugh, cry a lot.
Good Lord. But at the time, the Spirit Arena didn't exist, so we still did things in the the Coliseum over there. But we were rehearsing for graduation in the Monterey Auditorium, and I was sitting there in one of the seats, and the vice principal comes up, grabs a handful of my hair, and jerks my head back, and says, "If you don't have this cut by graduation, I guarantee you won't walk across the stage." So,
You should have just like.
being the totally non-smart aleck person that I am, I went. Nobody laughed when I said that. That's weird. I went. He just said get the haircut. He didn't say how short, so I just went and got a trim, and I kept the receipt on me. During graduation, I had my ponytail, and he didn't bother me. So I guess he either didn't notice it because he was too busy, or he just didn't care. No, it was like a centimeter. I mean, it was just a trim, like literally a trim.
You were like,
Because you said you need to have it cut. He didn't say how short. Okay. I don't know.
but, okay.
I'll think about it. That's the best I could give right
He
now.
said I had really long hair. He said, "Do you think he had hair?"
You actually want to know what's funny about that?
The question.
Honestly, true story. I did not start losing my hair until I started teaching high school.
Sorry. But you should still bring a picture.
It's I don't know.
This is
I
the
think if
happiest
you're
Ella's
bringing
been in class.
Picture
I think this is the most engaged Ella has ever been with our material.
This is the most emotional she's ever.
Hey, what'd you learn today in math? Nothing mathematical. My teacher had long hair. Okay. All right. Subsets. Okay. Because Mr. West is boring. We don't need to keep talking about him. All right. So now I want the intersection of A and B complement. Okay. But with subsets. Okay.
Yeah, that is a good point. Is that if anybody has the right to laugh about hair, it is it.
Why?
See my hair constantly looks like a
You constantly look like a poo? A poodle.
yeah. My favorite
Oh, I'm sorry. Can I say
Yes.
one thing? Get back to it.
We never say anything off topic in here.
You know the dog, like the Labradoodle, like they combined a poodle and a Labradoodle.
Yeah.
The guy that like made that says like he did an interview and he says every day he feels like.
Is that you? Oh, wow. I'm sorry, I didn't mean to interrupt you, John Henry. You kind of look like that girl from The Ring, where the hair's all in front. Like your skin looks better though; it's not as pasty white.
Thank you.
There you go. Well, I mean, John Henry, what were you saying? Okay, let's get back to math. Okay, subsets. I got two.
No.
All right. Emma is going to help us out.
Okay, wait. Can I just go and say, I did the thing where you put the two boxes, and I got that you don't shade any of it in.
I don't know what you're meaning. I need you to show me visually. There we go.
That's why I'm confused.
So the intersection of A and B's complements.
This is just what helps.
Okay.
Is that right? Since B is a part of.
Well, it doesn't matter if B happens to be a part of anything else. The complement just says we want everything outside of B. So that does include what you shaded there, but it would also include those that are in A but not in B. Okay? And then A is all of that.
So they share the little crest. Like this.
So what do they share? There you go. That's perfect. Okay. That's exactly right. Okay. Is it starting to make a little more sense? Okay. Is it helping people if you do them separately before you do them together? Maybe a few folks? Okay. Okay. Cool, 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 cool. In fact, we're almost done. We don't have a whole lot left. All right. So application. So we have our first official Venn diagram. The classes offered at a summer camp are crafts, volleyball, and swimming. So C, V, and S. There you go. The Venn diagram shows the number of children involved in each activity. So like if I were to take any of these three items individually, like how many children play volleyball?
13.
Okay, 13. See, I can pull that information off the diagram because I'm looking, it doesn't matter the way I ask the question, okay? It doesn't matter if they are in crafts or if they're also in swimming. I just said, how many students or children take volleyball. So I'm looking within that particular circle. Okay, so try this one. Take about a minute to go ahead and answer A, B, C, and D. Okay, try it individually. Try it on your own first. And then let's come back together and see if we can get the same answers. If you want to go ahead and check with your villain buddy, okay, go ahead and do that. With the first question, how many children are in only the crafts? Okay, is everybody about ready? Okay. All right. No. Yes, that is right there. That is C complement. Yes. Okay. All right. So let me go ahead and give you the three answers. Let's see how we did. Okay, for A, 8. B should be 4. And then C should be 19. So it should be 8, 4, and 19.
8.
Yes. Okay. So let's talk about these.
Oh, I get it.
Oh,
Do we have any questions on A?
no.
Okay. Now, what region are we actually talking to? It says how many children are in only, and that's the key word there, only the crafts class. So I don't want to look at any other child that also takes volleyball or swimming. So I'm only looking at this region right here. Now, if I said, how many children are in crafts class, see, that's a completely different question. Then I would probably go ahead and say, what, 14? Is everybody okay with that? Okay. Let's talk about B. How many children are in both the crafts and volleyball? Okay. Well, what am I looking for? What's the key word there? Both. Okay. Both crafts and volleyball. Well, here's crafts. Here's volleyball. Okay. So the intersection of the two, crafts and volleyball. So that's only 4 students. Is everybody okay? Okay. And then now, this last one here, how many children are not in the crafts class? Okay, well, I want to go ahead. So basically, this is the verbal equivalent of saying the complement of C, okay, not being in the crafts class. But I'm only noticing 15. Where's that 19 coming from? Well, what's this forming? There you go. See, they still belong to that universe, but they are not involved in any of those 3 groups. Okay, does that make sense? Okay. How many people got all 3 of those right? Okay. Nolan, you raise your hand and then you put it down quickly. We were close. Okay. Does anybody have any questions? Okay. Well, I mean, there's a lot to do at camp besides crafts and volleyball and swimming. Maybe there's a... What do you do? I never went to camp. What do y'all do at camp? Surely not everything can be encompassed by crafts, volleyball, and swimming. What about if there's like baseball or flag football? Did they do any other kind of sports at camp? Capture the flag. Okay, there you go. So there are options. You know what? I mean, it's a pretty weak camp anyway. All right. Now, D, shade the part of the Venn diagram that represents the intersection of C's complement and S. Who would like to show me this? Joe, you want to do it? Okay. Okay, so think about it. I'm looking for the intersection of everything outside of circle C, but also S. Okay, what do you guys think? Unfortunately, we're not right. That's okay. That's okay. Hey, that's okay. That's why we're doing this. Okay, that's all right. Reese, you want to try? Okay. Hey, that's what. No, fine. Yes. I like the way she finished that at the end. So you're saying just this little bottom crescent region. What do you guys think about that? That is correct. Yes. That is what we're looking for. Okay. Again, did anybody happen to go ahead and draw 2 other Venn diagrams outside and then kind of compare the 2? I find that when I was first learning this, that really helped me out. Okay. Especially to visually see what's going on. So what would this shaded region represent? What kind of students would it describe? Yeah, well, the students involved in swimming and volleyball, but not crafts, because we do have that small group there that is both swimming and volleyball. In fact, there's 7 total, but only...
Well, but they could be.
What's that?
Never mind.
Okay. Amy?
Why would it be and in volleyball? Because I know it overlaps with volleyball.
Uh-huh. So we have these 4 kids.
Then it would also imply that it was volleyball, all of swimming, but not the part that includes the crafts circle.
Well, we just want to be really specific about how we say this. We're talking about kids who are in swimming and volleyball. See, that keyword there is telling me the intersection so that we don't include the entire thing. Just what each one has, what they have in common, but outside of crafts.
Could you word that more specifically? Like kids that are involved in swimming and volleyball.
because I think what Emmy's.
I mean, I guess I can see you're right, but wouldn't that be a little redundant, though?
I know, but I think Emmy's confused because she's like saying that if you say swimming and volleyball, that's like implying that it would be swimming and volleyball.
I mean, okay, I guess I get what you're saying.
Mr. West,
Okay.
could you say like the kids that are in swimming but not in crafts, and then that doesn't say only swimming and not crafts, and then that would do the 6 and the 4? It just means that
Okay,
swimming
I see what you're saying.
not all swimming.
Okay. So, Amy, does that help?
Yes.
Okay. So there we go. It was just how we were saying. Okay, good. Okay. And then here's our last problem right here. Okay. It says during a 2-week period, Muriel took an umbrella with her on 8 days. It rained on 9 days, and Muriel took her umbrella on 5 of the days when it rained. Display this information in a Venn diagram. Okay, so I'm going to give you 1 minute. I want you to go ahead and construct this Venn diagram. Now, I'm going to go ahead and give you the template. You've got your universe here. Okay. Now, we're going to have overlapping quantities. And what are my 2 quantities that I'm referring to? Okay. Okay. It looks like days when it rained and days what? When she took her umbrella. Okay. So let's say one circle is R and the other one, I don't want to go ahead and put U because I like to put the universe U outside. So what's another letter we could use for umbrella? T.
Took umbrella.
Took umbrella. There you go. There you go. Terrific. There you go. Okay. All right. During a 2-week period, Muriel took her umbrella with her 8 days. It rained on 9 days, and she took her umbrella 5 of the days when it rained. Okay. So one of the things you have to figure out here, how many elements are in my universe? Now, don't say it out loud. Okay. And what do those elements represent? Now, one thing I'll go ahead and mention, when you construct a Venn diagram for me, on the outside, typically what we like to do, we go ahead and put U on any of the 4 corners. It doesn't matter which one, but you always go ahead and list the number of elements in that universe. Okay. That's why I didn't want to use U. All right. Okay. So let's start there. Maybe it'll help some folks out. How many elements are there in this universe? Oh, not 2. 14. Because what are we talking about?
2 weeks.
It's a 2-week period. So we're talking about days when it rained or days when she took her umbrella. So there's 14 days total. Okay. Is there anything anybody can tell me that we know for sure? 5 would go in the middle. Okay, she took her umbrella with her 8 days. It rained for 9 days. She took her umbrella 5 of the days when it rained. We're describing the what? See, that's why I drew it as an overlap. On 5 of the days when it rained, she also took her umbrella. That's the intersection. Okay.
She took her umbrella 3 days. Did not rain.
Now, how are you figuring that out?
She took her umbrella with her 8 days.
There you go.
Her umbrella with 5 days.
Now,
Minus 5.
if I'm able to find one of those sections, John Henry is absolutely right. I know that the intersection of it raining and her taking her umbrella, that happened 5 days, right? But it told us that she took her umbrella with her 8 days. So if I've already accounted for 5 in this circle, then there's just 3 right there. Okay. Now again, there are 5 days that it rained where she took her umbrella, but how many days total did it rain? 9. So the full circle for R should be 9, so I got to put 4 here. But does anybody notice anything? So what does that mean? There you go. There were 2 days where she did not bring her umbrella and it did not rain. So if you have an element, as we saw it in the previous example, that's still in the universe but not belonging to a set, well, you just write it over to the side someplace. And it doesn't matter where I place it, as long as it's still within the rectangle. Okay. How many people had that set up correctly? Or at least on the right track? Okay, good. Okay. Well, now let's answer these two questions, and we are done. Find the number of days that Muriel did not take her umbrella and it rained. Okay. So kind of think about what we've been doing graphically, right? What's the key word here? And. Well, and goes with what idea we were talking about since yesterday? Starts with an I. Intersection. Okay, so think about it. The days that she did not take her umbrella, we're representing the days she took her umbrella with a T, right? So the days she did not take her umbrella, that's equivalent to taking the complement. Okay. And on days it rained. Well, how are we defining a day that rains? Just R. Okay. So really all we're doing is we're verbalizing what we've been doing yesterday and today. We're looking at those expressions. Okay. So in fact, can anybody tell me what that is? It is 4. That's exactly right. There were 4 days when that happened. Does anybody need me to shade that? No? Okay. All right, try this last one. Okay, don't say it out loud. Okay, if you haven't already got the answer, I'll give you a few seconds. Find the number of days that Muriel did not take her umbrella and it did not rain. Okay. So maybe it'll help to take that and write it as an expression using our intersection. Because again, it's telling me and. Okay. Now keep in mind, if it said or, that would be completely different. Okay. Or is the union, and is the intersection. Okay. Now, can anybody tell me the expression that this would relate to? Okay. So I heard T prime intersecting R prime. So remember that prime, that's the complement. Okay. So what would the intersection of those two be? It is just 2. That's it. How many people had that right? Good. There's a lot more hands going up. There we go. Nice, nice, nice. Okay. Now, you got your homework assignment. What I'm thinking is that tomorrow, probably budget maybe 15, maybe 20 minutes. I'd like to go ahead and spend the rest of the time, looking at the assignment. But we definitely won't have time to look at the entire thing. I mean, we still got maybe a good 7 or 8 minutes here. I would like to try and turn this in tomorrow. That way you don't have any homework for the weekend. But that's just my thought. Okay, would you rather have it turned in tomorrow or on Monday? Monday?
I think would we rather that the due date be tomorrow?
Tomorrow or Monday, that's what I'm asking.
Okay, good.
Remember, regardless, I'd give you time to work on it. The thing is, I would just want you to look at some of the problems, because some of these are very reflective on what you'll see on not only my tests, but also the paper exams. They like their Venn diagrams. Okay. And they seem pretty easy, but they can get kind of complicated sometimes, especially the last ones on your assignment. So I just want to make sure that everybody at least looks at it, maybe comes in with questions. Does that make sense? Okay. So how many people want it due tomorrow? Oh my gosh, everybody's hand is raising. So you can't say I'm lying because there's no visual here. It's just audio. Okay. So I guess we're doing it Monday. Yes. Okay. Monday it is. All right. Yay. All right, so I guess what we'll do tomorrow is after we take care of that chi-squared exit ticket, I'll go ahead, we'll get some folks up here to kind of demonstrate some of these problems and help each other out. Sound good? Be a good way to end the week. All right, thank you guys very much.